Morning guys, today's lesson is about using prime factors to calculate roots. So that is basically to use your prime numbers, for example, to calculate maybe the square root of 9, for example. Now we know that the square root of 16 is equal to 4, and that the cube root, for example, of 8 is equal to 2. Now I'm going to show you how to use prime numbers to calculate those roots. Can we do this example first? Okay, if you need to calculate the square root of 16, for example, you take that 16 and you use the ladder method. So if you look at our prime numbers, the first prime number is 2. Can 2 go into 16? So it's like long division, we divide it. 2 can go into 8. 2 can go into 2. 2 can go into itself once. This here on the left hand side is our answer that we want. So it's 2 times 2 times 2. That basically gives me 4 2's. I take that and I put it in place of the 16 in the root. It's still square root, not of 16, but of 2 to the power 4. Now, what does the rule say regarding when the exponent is in the root and exponent outside the root? According to the rule, we must divide the exponents to get rid of the root. So we keep the base and we divide the exponents. Take note, there's no root because we got rid of the root. Let us continue. 4 divided by 2 is equal to 2, and 2 to the power of 2 is equal to 4. Of course, we know the answer already, but I'm just showing you a calculation of how to use prime numbers. How to use prime numbers to get the square root of 16. Just to recap, when you must calculate the square root of a number, you take that number and you factorize by using prime numbers only, and we use the ladder method. So 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 twice, 2 goes into 2 once. That will be 4 2's that I'm multiplying, and I write it in the exponential form. That I take and I put it in my root in place of the 16. So I'm not changing the sum stays the same. Then my rule for exponents is that if there's an exponent inside the root and one outside, then I divide. I keep the base, I get rid of the root. So it's 2, keep the base, and 4 divided by 2. That gives me 2 to the power of 2, which is 4. So now we can say that the square root of 16 is equal to 4 using prime numbers to calculate the square root of 16. Let us look at another example. Okay, let's say it's a cube root of 8, for example. Right, we take the 8. We use the ladder method. The first prime number is 2. Can 2 go into 8? Yes, 4 times. Can 2 go into 4? Yes, twice, sorry. Can 2 go into 2? Once. There's our answer. So it's 2 times 2 times 2. That gives me 3 2's that I'm multiplying. I take that and I put that in place of the 8. So it's still the cube root of not 8, but 2 to the power of 3. Then we apply the rule that says if I have the exponent inside the root and outside the root, then I must just divide the 2. 3 divided by 3, so that gives me 2 to the power 1. And as we know, any number to the power 1 is equal to that number. So, which number did I multiply 3 times by itself to get to 8? That number is 2, and it is 2 times 2 times 2 gives me 8. Okay, I hope you're happy with that. I would like to do another example before we end off. Let's say the number is 36 and it's a square root of 36. Okay, we do the ladder method. Right, 2 goes 18 times, 2 goes 9 times, 2 going to 9, so my next prime number will be 3. 3 goes into 9 3 times, 3 goes into itself once. This here on the left hand side is my answer. So it is 2 times 2 times 3 times 3. If I write that in exponential form, it will be 2 2's times 2 3's. I take that and I put it in place of the 36. It's now the square root of 2 square times 3 square. Same principle, inside the root, outside the root. So to get rid of the root, I've got now 2, and I take that and I divide, times 3, keep the base, 2 divide by 2. That will give me 2 to the power 1 times 3 to the power 1. That will be 2 times 3, and the square root of 36 will then be equal to 6. Thank you. I will post a note as well as an activity for you. Thank you and enjoy the rest of your day.